Welcome, dear students. Uh, Many queries are coming from the viewers. Today, I thought I take one topic. The, the confusion is that why cross-pollinated crops show more inbreeding depression than self-pollinated crops. Here I would like to clarify through a hypothetical example which is very easy to understand. I'm putting it on my paper. This is here I want to say that you please see that sorry, the question is cross-pollinated crops show more inbreeding depression than self-pollinated crops. Why? Now you see the nature of cross-pollinated crops. What is the nature of cross-pollinated crops? You see, the genetic architecture, of cross-pollinated crops, we used to say that heterozygous in nature. Means majority of the loci are in heterozygous condition. I'll let you know here. I'm putting one example of any OPB variety of maize. If you put, whether that will be, this will be the genotype, or this will be the genotype, or like this OPB are synthetics or composites, not hybrids. Because in natural condition, whatever you are having in cross-pollinated crops, they are open pollinated variety. So their genetic architecture, we used to say that heterozygous. They are heterozygous in nature. What do you mean by heterozygous? Means majority of the loci are in heterozygous condition, and that is why if you count that, you will be finding it is maintaining. If you are maintaining the Hardy-Wimber equilibrium, the proportion will be 1:2:1. Capital A, capital A, capital A, small a, small a, small a. This will be the situation of all types of genes in all loci present in cross-pollinated crops. That is why we say that capital A, small a, P square, Q square, 2PQ. So we say these type of genotypes as a heterozygous genotypes. Now I'm putting hypothetical example for different types of genes. Say for example, here on this locus, capital A, small a. Small b can also be present, as you see that here 1:2:1. Capital C, small c in this, capital D, small d, capital E, small e, small f like this, small g like this, capital H, homozygous also you will be getting like this. This is the situation, this is the genetic architecture of cross-pollinated crops. Small e, capital J, small j, capital K, small k. In this situation, in this way, you are having the genes located in these crops. Another variety of cross-pollinated crops, another OPB, another synthetic or another composite, if you see, capital A, capital B, small c, capital D, small e, D, small e, small. So this is different from this. Both are different OPB, both are different synthetics, both are different composites, and they will be in natural condition. If you are following the Hardy-Wimber equilibrium, they will be in this situation. You will be finding this type of genes are preserved. This will be in equilibrium status. maintaining 1:2:1 ratio. But here you try to understand that cross-pollinated crops are heterozygous in nature. So if they are heterozygous in nature, forget about these where you are finding the homozygous, forget that. Wherever you are getting the heterozygous status, if you are selfing this variety, what will happen? You are going to get capital A instead of capital A, small a. You are going to get capital A, small b, capital C you may get, or small c you may get, or capital C, small c you may get. Capital D, you may get small d, you may get capital D, you may get capital D, small d. For capital E, small e. So if you see that in majority of the loci, they are coming to a heterozygous condition, and wherever heterozygous condition, if you say that in majority of the cases we find that dominance is the cause of heterosis. If you, in majority of the cases, we accept that dominance is the cause of the heterosis, means dominant counterpart of locus is beneficial, whereas the recessive counterpart is deleterious. So if you are getting recessive like this, in majority of the loci, what will happen? So they are deleterious. They will give the negative impact on the potential for particular for expression of the particular gene. So inbreeding depression, of course, will be higher in cross-pollinated crops as compared to self-pollinated crops, because majority of the loci are in heterozygous condition. When you are selfing, they are going to become homozygous in many cases at deleterious alleles, with deleterious alleles. So that is why they are going to give you the depression in the individual getting the recessive alleles in homozygous condition. Now you come to the self-pollinated crops. Self-pollinated crops, the genetic architecture of self-pollinated crops are homozygous. In almost all the loci, you are finding homozygosity: small a, capital B, capital C, small d, small e, small f, capital G, small s, like that. Here in another variety, capital A, small b, small c, capital D, capital E, small f, like that. These are the genetic architecture of the self-pollinated crops. They are homozygous in nature. If you are selfing them, you are going again to get from, if you are selfing this, you are going to get this, the same. So where will be the depression? There is no reduction in anything in this genotype after selfing. And in this genotype also you are going to get the same. So there will not be any depression in self-pollinated crops which are in homozygous condition. So you should not confuse that why you are getting more inbreeding depression in cross-pollinated. That is why, because they are in heterozygous condition, which is going to give you the homozygous condition in next generation after selfing. So I think it is clear to all that why you are getting more inbreeding depression in cross-pollinated crops as compared to self-pollinated crops. It is now clear to all. And if you like, you put the button of like, and you must comment, must make some comment. If you liked it, in that way you have to comment. Then only I can get something to understand that how can I improve, or if it is good, I can give you more topics. So please go for like as well as give your comments. Thank you very much.